Hi everyone. In this tutorial I'm going to be showing you basic modeling techniques, particularly the revolve and sweep commands in Rhino. So we're going to start by importing a drawing to use for this type of model. So I'm going to go to View, Background Bitmap, Place, and then I'm going to find the Tuscan columns file that I had, and then I'm going to place it on my desktop. Now this has a scale bar, but it's somewhat modular drawing, and you can see that the proportions are somewhat marked by these arches. So what we're going to do is kind of take a measurement and assume that this column base is 1 by 1 meter. Right now my units are in millimeters, so I'm going to change my units to meters. To do that, I go to Tools, Options, Units, and then I do meters. I hit OK. And after I do that, I want to scale this to be 1 meter. So what do? I go to View, Background Bitmap, Scale. So I choose this corner as my origin. I can hold Shift and then measure this as, right now it's 3.74. I'm going to click on that to take that measurement, and then I'm going to type in 1 because I want that dimension to be 1, and it's going to give me a line that is 1 meter in length, and I'm going to click again, and that will make that measurement we took as 1 meter. So right now this is somewhat 1 meter. Now I'm going to start modeling the column first, and you can look at the drawing and see that it's has a partial section, partial elevation, and a partial plan. So we're going to be modeling this corner of a I think this is a Doric temple. So we have, let's start with the columns. To do the columns, what we need to do is take this profile and then specify the axis for revolution. And to do that, I'm going to create a new layer. Let's call it the column. Give it a color we can see in the background, then activate it. Now what I want to do is come down here, take this datum in the section drawing. So we can just add some drafting lines, and then I also want to find the axis for the column. So what I want to do is draw a 1 by 1 square here. So that's a 1 by 1 square. We can see that it's actually not a perfect square, but that's totally fine. Now let's find the center of that square. It's right here, and then I'm going to draw this up. These drawings are lined up, but I still need this axis line to do the revolution. And then this part of the drafting is somewhat doing the offsets. So I need to find this measurement, which is somewhat, let's say 0.2. So I find that line, I do offset again. This guy is going to be 0.15. And this guy is going to be, let's say 0.025. So that part is done. Let's do the total height, which is going to be, I think, somewhat around 5 meters. So I'm going to do the total height as 5. So I find this line, 0.025 again. I'm kind of replicating this movement here. And then we can do 0.15. I found that, and then we can do this part. It's going to be, let's say 0.1. This could be a bit more, I think. It doesn't have to be perfect. We can just take the measurements that we see fit. Let's make this as 0.1 again. 0.025. Let's do 0.025. Found that. And then this guy, let's do 0.1. .025. And that should kind of do it. The next part is finding these horizontal offsets so that we can draft it. This guy is 0.5. And then we're going to go in a little bit. Let's find this corner, which is going to be, I'm assuming, 0.1. And then we don't need any other offsets here. Let's find some on top. This guy, I see 0.35. 0.35. Let's take it as 0.1. So I have a few offset lines. So what we could do is go over them and then try to draft this profile here. So I'm going to create a new layer, call it the profile. Let's make this green, activate it, and I'm going to lock the column lines because we are not going to use them necessarily. We're going to draft on top of them. So I go here, and then I need to find the semi-arc here, and then I have another half arc, I assume. Actually, this is somewhat here. It seems like it's somewhat inside. Let's try to draft it. Yeah, it's somewhat here, and then I'm going to extend this line to be here. This guy is going to be another arc. So we could make it like this. I can just drop this line, and then that will be here. There's going to be a curve here. We haven't done the curve yet. Let's move on top. So I'm going to start from here. We're going to drop this corner. This is going to come down here. Then we come in here, and then we're going to drop this guy. Like this, and then that will be here. Where that ends, I'm going to have another profile, so that's going to be like that. Can move this guy here, so I'm somewhat catching up the exact measurement. I think this is a semicircle again. It's a small semicircle, and then we have, I think, a straight line, and then from here on it is a curve. So let's draw it as a diagonal line first. So I'm going to draw this line to that line, but you can see that this curve somewhat moves in a different fashion. So what I want to do is rebuild this curve and then try to give it the outline of the column somewhat. Let's go over some of the curve tools first. So when we draft a polyline, we basically can visualize the corner points using the points on command here. So this will give me the points, and to visualize these arrows, you can turn on the gumball, and you can move the points anywhere you want. Now, if you want to change the degree of this curve, we can rebuild it. Now it has 5 control points, but it's a degree of 1, and the degree means the way the data is interpolated between the points, so to draw the curve. So if it's a first degree curve, it will be a polyline, so there will be linear interpolation between points. If it's a third degree curve, then it's going to basically have a third degree interpolation, which means it's going to take in multiple points to draw its outline. Now if I keep the point count but turn the degree to 3, you will see that the points are somewhat kept, but the interpolation somewhat affects the outline of the curve. And the rebuild tool, what that does is basically it enables us to increase the information on the curve and draft it more accurately to NURBS outline. So I'm going to rebuild this. I'm going to start with 4 control points and a degree of 3. I'm going to hit OK. And then I'm going to visualize control points. So what I want to do is draw these somewhat to get the get the curve outline. So I'm going to move this back into its position. I'm going to turn on the control points. This point I'm going to move slightly to the right, to the left, and then this one I'm going to move slightly up, so that we get a shape that is somewhat resembles the column outline, but you can see that there's a slight movement here as well. To do this, I need to include more points here, and to include more points, I need to open the cascade in the point edit toolbar, and then here we can add more points. So if I do an insert control point, I can insert multiple control points here to my curve. Then when I visualize it, I can choose these and use the information to give it more control. So I'm going to include one more control point here. Now I have two. I'm going to move this guy slightly to the right and this one slightly here, so that the curve is somewhat kept. I'm going to play around with this a bit. You don't have to do any type of complex manipulation. You can just like move them horizontal or vertical. So that's kind of the outline I got. So it has somewhat a deviation in the middle. So let's move this back a little bit. That seems to me pretty accurate. Now we have finished the profile, which is here. So I'm going to choose all the curves in the profile, which are these. I'm going to type in join to join them, so that make sure that everything is connected. Now here is the fun part. So what we're going to do is we're going to revolve this profile along the axis line. So I type in revolve, choose the revolution profile first, confirm it, and then it says start of revolve axis. So I'm going to choose the axis line, and then start of an angle is going to be 0. So depending on how much we want to revolve, if we want a half a column, we can do a half a revolution, which is 180, but it's a full column, so you're going to do 360, and that will give us the column model that we want. Now you can see that it produced a surface, so it's an open geometry, and we want to close it. To do that, we can just type in cap. Cap will close open geometries, and it will give you the shape, the closed volume that you want. Now that we have the column, I want to place it in the exact position. Now I actually recognize that I made a mistake, which is this part at the bottom. That is going to be a square base actually, and then the column starts at this location. So I'm going to delete the profile first, explode it, deselect these portions, join again, so that we revolve this part instead, and that part is going to be just a simple extrusion. So I'm going to type in revolve again, choose the profile, choose the axis line, so I get my shape. Now I'm going to extrude this profile in plan, and the height was 0.2. I'm going to choose this part, type in extrude, type in 0.2, so that's the base, and move this guy on top of it. So I'm going to first cap it. The next thing is we can rotate it using the gumball, and then I want to place its center to the center of the square. Then I can move it by 0.2 up, so that the column is in place. So that's one of the first columns, and if I want to join these two geometries, I can just type in, if I want to make them into one geometry, I can just select both of them and type in Boolean union. That will join them into one geometry. Now we have 3 columns, so I'm going to create more copies of the columns. But let's start working on the plan a little bit more, because we have steps here. So what I want to do is copy the columns, model the steps, and then the last part we're going to do a sweep to do the top portion. So let's unlock our drafting lines, so we can call this as drafting. I'm going to choose the axis line, type in offset, distance is going to be, let's take a measurement from here, offset distance. So my columns are somewhat 235 away. So I'm going to specify that as the dimension. I'm going to offset these axis lines. It could be slightly off. We can also make it 2.4. 2.4. So let's say those are where the columns are. I'm going to choose the geometry, type in copy, go from here to here. That's somewhat created an irregularity. Let's make it 235 instead. 235. And then I'm going to copy 235. Now I want to draft the steps. To do that, I'm going to start from here. Just draft the edge of the columns. Draw this line. Now the column, the first step is somewhat offsetted from that, so I'm going to take an approximate measurement, which I get as 0.03, and then I'm going to offset this curve. So that's where the first step is, and then the second step is going to be, let's take another measurement. It's 0.35. So I'm going to have 2 more steps. So that's the plan of my steps. So let's look at it in plan. And these, the first step is going to be located at the bottom of the column, right? So that's what I see. And then let's take a measurement of the height of the step. The height is going to be 0.18. So what do? I want to first model, let's say, this step. To do that, I'm going to finish drafting it here. I'm going to come down here, go up to an approximate dimension, and then close this here. So these lines is going to be the first step that is located at the bottom. So I'm going to trim it, select these guys, join, and then I'm going to extrude that curve 0.18. And this step is going to be located at the bottom. 0.18. And basically I'm going to then move this down. Let's see, we have another step here, another step there, so this is going to be 2 steps down. So then I'm going to choose this, move this down by 0.18, so that's where it's going to be, and this is the top surface of the step. So we can do it like this. There's also another way of modeling it. For instance, we can model the section of the step. We can model the section of the step. Let's delete this guy. Actually, let's keep it. Let's do a trim. So you guys get the point. So this could be a sweep or an extrusion. If I want to model this out of boxes, for instance, we can just start with a box here, from here to there, and then move this down. And then I can use scale 1D and then model the step in a few segments, right? I can just copy this, scale 1D, get this width measurement, and then get this depth measurement, make another copy here, scale 1D. I'm basically using the same geometry to model that as a base, right? So that's the second step. And the last step is going to be just we can just draw this as a planar surface and then extrude it, right? It's the same thing as extruding an outline. We do a trim again. So this guy and this guy, we can just join it. Extrude curve minus 0.18, minus 18. So that step is located here. So that's the first base. That's actually going to be a bit more down. There's somewhat of a discrepancy. Let's extrude this curve again all the way here. That looks better. So now I finished the steps, I finished the columns, and what I want to do is basically use the sweep tool now to model the top portion, and then and this pediment will be done basically. So what do I want to do? I want to first draft this outline and then sweep that on a rail. Let's go back here again. I'm going to delete some of these lines. We don't need these drafting lines anymore. And I want to just draft this profile. Actually, let's bring the column axis, which might be a bit helpful to offset these lines. And then from here, 0.32, 0.3. So let's take that as that line. Then I'm going to do 0.55. And then let's find the height. The height is going to be from here. Let's take this measurement. 1.55. It's sort of drafting, but we want to be precise as possible. And then we come down from here, 0.25. Now there are a lot more lines here. To save some time, I'm going to do this as quickly as possible. And you can see that I'm just drafting the lines. So I'm going to take another measurement, 0.05. I'm just going to go over this, somewhat eyeball it. Let's take this line as somewhat the measurement. And I'm going to close this line. Let's take this measurement. And then this is the base. Actually, let's do this a bit more precise. Let's offset these. Let's find these points. .05. This line is going to be 0.3. .15. And then from here to here, 0.15. 15 again. So I'm seeing two profiles here. This is a diagonal line, so we're going to draft it with this profile command, and there's kind of a kink here as well. Let's find this measurement, which is going to be 0.25. And then this line is going to be 0.1. 0.1 is too much. Let's do 0.075. Okay, now we can draft it. I switch to the profile. I come down, go diagonal. From here, it's basically a few geometries, so I need to find this point. And that point is located at 0.1. So from here to there, it's an arc. And to model that, I need to find this point as well. Let's take that as 0.05. I found that corner. Now, we can do this in a few ways. For instance, under the arc command, there is arc with 3 points. We've been using center, start, and angle, but if we use this, we can specify where the arc goes and then specify a third point like that. And then I think there's another one here like this, and the profile then comes down. I'm not going to model all this geometry here. Instead, what I'm going to do is come down here, 0.05, and then 0.1, then go down here, and that 0.1, I'm going to find its midpoint and draft this. From here, I'm going to come down 0.05, come down in 0.025, and from here, how much do we have to go down? 0.05. Let's find this point. So we can use arc with 2 commands again. And then from here to here, let's find that point. 0.05. That might be okay. You can also use this start, end, and direction, for instance. If we specify start, end, and this is our direction, it's going to, well, that's actually takes it from the start, but if I specify this as the start, this is the end, and then specify this as the tangent, so that will create this nice curve that we need. And then I'm going to close this profile by going down. And here I'm going to go in and go down. So that's kind of the end of the profile. I'm going to hide these lines, delete these lines, trim this portion so I have this as the whole profile. I need to round this up, so I can do fillet to do that 0.5 and then select this end and then round it up. So my profile is done. I can join it. And what do I need? I need to move this in place. So I go down here, grab this curve. What I want to do is rotate it in 3D and move it to somewhat to this face, right? So perpendicularly to this face, and then I'm going to move it up. I can do that in section. So I'm seeing this in the front view. I'm going to move this up on top of the column. Now, if I try to do this orthographically, I'm going to grab some of the points from the column and it may not work perfectly. So I'm going to turn on project. And what that does is it takes the measurement from the coordinate system and it moves it and it allows you to take some reference, but it only moves this up. So I'm going to move it now and take the measurement from the top of the column. So that profile will move in place, but it won't move in 3D basically. It will move along the plane it was located at. and then I need a profile curve, and my profile curve is going to be here. I'm going to move this up. Turn off project now, move this up. Now that profile curve is going to be here. I'm going to explode this, the curve I took from the plan, join this portion. I can also draft a line in the plan, but we can just take this line, this edge, and then offset it to the profile, right? So basically this is going to be the rail on which we are going to sweep the profile, and this is going to be the profile. I'm going to trim these portions. So that's going to be the ceiling, the bottom of the ceiling, and then there's going to be a profile here. Let's model the profile first. I'm going to use sweep 1, select the rail, select the profile, and then hit OK. It's that simple. So what it does is it basically uses this profile. It uses this profile to extrude it along a rail that we specify. So it can take that corner, go in and out. And then I need to close all of the exposed faces. I'm going to start with the bottom face first because we want this to be a solid geometry. I'm going to type in planar surface, so that face is going to be closed. And then we can close this face here and the top face. Let's draft some more lines on top. I'm holding shift on my keyboard so that I'm doing orthographic projection, and I'm snapping to perpendicular geometry. I'm going to trim these and these. So the planar surface is basically how we define how we close a face. So we close the top face. Now I need to close this corner. That should be really easy. I can just draft another line there. Type in planar surface. You can choose all of these faces using the marquee tool to choose them, and then type in planar surface. That face is closed. I'm going to try to close this part. I'm going to choose this face. It says that it's because it has a complex profile, it's going to use curve Boolean processing. We can say yes. Most of the time it works if you have drafted this accurately and you don't have any irregularities in the curve. I'm going to do the same on this face, and that is closed as well. So right now the top portion is closed. So this model could be 3D printed, for instance, because it says solid geometry. And I'm going to hide. Let's choose all the solid geometry and put that in a layer. I'm going to type in 3D model, select poly surface. Will give you all the surfaces we modeled. I'm going to move that to 3D model. Hide them for now. Select surface. Let's choose these guys as well. Put that in the layer. I'm going to hide the curves. Choose the top portion. Type in join. Then that will be a closed geometry as well. So right now, this is a water type model. We can do the same Boolean operations at the bottom. Now let's go over some of the Boolean operations. For instance, we can, if we want to join geometries, we type in Boolean union. So let me write these down. First, I'm going to draft some geometries. So let's say we have a cube and we have another cube. Now, Boolean union, the Boolean tools are located under solid tools. It's the first on the tab. Now, Boolean union basically joins two geometries together so they become one. Right, the intersecting geometry will be included, so the volume is basically resolved. Now, similarly, if we do Boolean difference, so this was union. Now, if I do difference, Boolean difference. So it says select surfaces or pole surfaces to subtract from. I want to subtract from this. I want to subtract that. And what it does, it basically takes that portion off. If I choose delete input, it will also delete the geometry after it's done. Similarly, intersection and split, they basically give you, let me do this again. So Boolean difference, let's do Boolean difference again. I want to Boolean, I want to subtract from this guy. I want to delete the input. I want to subtract this guy. So it will take that portion off. If I do the intersection, select first set of polysurfaces. I want these, and then I choose these. It will give you the intersecting geometry. And if you want to split, you choose the polysurface split, which is this guy, and you want to split them with this. It's basically what it will do is it will use the second geometry to split the first one and give you the remaining parts, basically. So those are the Boolean operations. Now the Boolean difference is going to be quite useful when you want to model voids in a wall. So let's do one quickly, a quick example. So I'm going to model a wall, and let's say there's a window with an arc on this wall. So I'm going to go to an elevation view, just going to draft some window there. So dimensions are not that important. So I'm just going to model a window. Let's see, there's a semi-arc on top as well. We can model that like this. I'm going to explode this curve and then join these. Now if I want to do a Boolean difference, first thing is I want to move this guy all the way to the back a little bit more, and then I'm going to do extrude curve, and I'm going to extrude it on both sides so that it becomes a protruding geometry. And then I'll do Boolean difference, so I choose the wall, confirm it, and then choose this guy, and then create my opening. Then I can model the adjacent details for the window inside. Other geometry tools we somewhat covered. There's basically extrude curve. So any type of geometry, you can just do extrusion. So you can extrude it and then type in the dimension. That's simple extrusion. And we did sweep and revolve, right? So the sweep was basically using a profile and a rail, and then it was extruding a profile along a rail. And then revolve we did to use for the columns.